Good afternoon, everybody. Welcome to week 3 module. So this is week number 3 module, where I go over lecture 7 that has 3 parts. The first part is about binary images, which is one of the important tools that we use for both image processing and for computer vision techniques. Why is it important? It is very simple technique that you can use to identify the existence of things. For example, if you have a camera, let's say that this camera watching a farm. So I have, this is my farm. If I have a chance, so this is important concept. If I have a chance to take a picture of the scene where there is nothing in there, I can call that as background frame, background frame. So that will be my 0 frame that has nothing moving in there that I'm looking to detect. And any frames means like when you take a video, for example, you can set up the rate at which your camera collecting frames, 64 frames per second. So that's how many images will appear in 1 second. So your vision will see it as a moving thing. We call one of them frame. So if this is image number 1 coming, and there is some moving object in it, when I subtract, I have I1, so the difference will equal I1 minus background. So the difference between them, so anything that was there before, a building, a barn, a rock, a light post, whatever was in there, let me make that we have a barn there. So that's still there in the farm. So anything existed before I1, new scene, will cancel each other. So when I subtract I1 minus the background, the difference between them will stay only the new things that appeared in the scene. So the very simple detection for the existence of these new objects in the scene is to set up some threshold value. So the difference D will be something like this. It will not be perfect shape that we had there. So the values here will be very different from the values around it. So if I set up a threshold for the value of the pixel that's greater than some threshold value, anything that above that value, I will assign 1 to it. I will assign 1s to it. These are just number 1. I assign number 1 to the value of the pixel. Anything below that threshold, I will assign 0 to it. What I'm getting binary image. Why binary? So I have the existence of something or not existence of anything. That means I have either moving object or there is none moving objects in there. So that image will be stored in my memory or the memory of my system in this form. So this corresponding to the car, that corresponding to that person, and everything else will be zeros. So this will be part of your project, most probably, depends on the application that you will do for your final project. But this step is very, very helpful to reduce the areas at which we are looking for the object of interest. So if I am interested in looking for animal, there is no animal here. So I I will call the animals as a positive example or the positive object that I'm looking for. Anything other than animals that appears in the scene, I will call negative example or negative class, or so the animal will be the object of interest only. But the binary image doesn't know that if the object of interest isn't there or not. That's another testing, another stage that you will search for the object of interest. But the binary image tells you the following. The binary image job is to tell you the following. Hey, there is two new objects in the scene. Go find out if they are animals or not. So I will assign one to any pixel that has a value greater than specific threshold, and I will assign 0 to any value that any pixel that has value below that threshold. How you pick a threshold? When you look at many different images, you will come up with a number that makes sense. OpenCV, and you'll find like many Python available, Python codes online, MATLAB, they have a dedicated function ready for you to use, and it has also automatic threshold that can be done through the function itself without you deciding. You could just give the images, and this function just read the parameters, because depends what parameters are available for you there. And then it will give you the binary image. You'll define the background, you will define the coming images, I1, I2, I3. These frames are moving as I'm collecting more frames through my camera. And then this function will give you the binary image already. But you want to understand, what does binary image mean? We use this a lot. For example, I teach another class called Seed Lab, where students build a robot that's moving. And while they are collecting images, it's easy for them to convert that colored image into binary image, do some image processing to fix things around, and you might go back to the colored image. It is easy to handle the binary image because it is a very simple identification of the existence of the new objects, newcomers to the scene. All right. Any questions so far? All right. So, for example, I was reached by a group of students from CS department who are implementing a project for one company around here. That company makes gloves for hands. And they wanted to offer their customers something online. So the customer will send the picture of their hand that way, this way, like a couple of pictures through their phone. And as you know, people taking photos, there will be different sizes for their hand. Is it close to the camera, far from the camera? So I suggested to them to use that like standard object next to it. Maybe I use like a can of Coca-Cola, the standard size one, right? So whatever you come back or forth, if you know the size of this, you can estimate what is the actual size of the hand by comparing their ratios, right? So for that purpose, the company that will make the glove, what they need just the shape of the hand, because they can do the measurements, right? The shape of the hand in different directions based on how so what they are trying to do, they want to make the glove that fits the hand exactly. There's no need for people to stick with either you buy a small size, medium size, large size, XL. No, I give them like size fits their needs. All right, for some purpose or for some reason. So we don't need the color. We benefit nothing from the colored image. But if I have just binary image, that anything is black except for the objects of interest, I assign ones to them. So by assigning number one, I get maybe binary image that like the one that's shown in here, like the one that's shown in here. All right. So this binary image would be enough for application like the one that I mentioned. If I go to advanced application, like in your project, I expect that you'll be detecting some objects, someone moving around, some people will like see if a ball thrown to a basket, if your pet, a cat, for example, is walking around, you want to do detection there, depends on the application that you are doing. So first, after you identify the background, means the scene has nothing in it, then you keep subtracting and creating binary image as initial guess, as initial evident if there is object in the scene. So it is just one stage definition for more complicated applications. So the binary image, this is a good example for it. As you can guess, which is not the only case, the computer, when the computer stores this image, if I'm interested in the moving objects, so this will be assigned 1. Each pixel value here will be assigned 1. 1 will be corresponding to the white color. 0 will be corresponding to the black color. You can convert that. Feel free to do the other way if you would like. But usually it makes more sense that I have a number 1 to represent the brighter color. Okay, that's just a standard, but nothing wrong with going the other way. Even the function itself can give you the other representation that will assign zeros here and ones there. But let's just stick with the convention. Just we usually do this. All right. So when I store this data, there is no need to store the zeros. In the memory, I store only the ones and the location of the ones. Where are they located? So the ones and their coordinates. So that also will reduce the amount of memory I'm using. Think of a camera that mounted on a balloon or in a drone. So we have always limitations in our resources, like the size of the memory, or when I process images, image processing and computer vision techniques requires a very powerful processor, especially if it works on online. At the same time, I collect video and I do the detection, for example, for security purposes or for self-driving car. So at that time, I need like a very powerful system. So I try to reduce the amount of data that I feed to my system. So it is a good idea to keep track only of the object of interest to be stored in my memory, to be processed by my processor. So that's another benefit. All right. So in this example here, the binary shown here means we define this. These are the ones and these are the zeros. So it is also called a logical type image, because you can assign true versus false for the new object or no new object. So it can be obtained by thresholding gray level images. So this depends on what kind of function you use. So when I collected the image of earlier scene, this is RGB image. RGB image, it's a colored image. That's the part number 3 of today's lecture, or this week's module. So each colored image represented with the 3 matrices, one to store the red color, and one stores the value of green color, and that third one, the blue color. So based on the mix of these 3 colors, you get any color in this world. Mixing red, green, and blue gives you any color. So there is a lot of data. If you can imagine that you have in 1 second, you have 128 frames. Each color of the frame is 3 matrices. So you have actually 128 times 3 frames to be stored in the memory. All right. For application like creating a binary image, I do nothing with the color. So many functions will tell you. That's why when you use the function, either like Python or whatever OpenCV function that you use, or MATLAB, you need to read the documentation. What should be the form of the images that you are subtracting from each other to find the binary image? You are not doing the subtraction. The function will do it for you, but you need to know what does the function expect from you? What should be the format of the image that you are feeding to that function? For example, in MATLAB, it expects that you will give the function gray level image. The gray level image, these all will be converted into one image, gray level image, with values that maybe goes from 0 to 1. So before I create the binary image in MATLAB, and even there is a function in OpenCV that requires you that you convert from RGB, from colored image, into gray level image. And then when you feed the gray level image to your function, this will give you the black and white image, or the binary image, that BW. All right. So we want to represent this as a 2D image, and it has the objects of interest in there. So there's no need to waste the processing time of my system or the memory size by using colored image. So that's one of the requirements for the specific function that you'll be using. Again, I'm giving you a general description. Depends on what function you use. Go to the documentation of it. The good thing with MATLAB, they have like a very good documentation, but even OpenCV, people have been using it in industry for a while now. People use C++ as well. There's many functions available online, open source for you. Feel free to use them. Just read the documentation that will tell you what are the parameters and what is the requirement. What is the requirement? All right. So binary image is a 2D image. And you understand what I mean by 2D now, because it's going in X direction, Y direction. Also, you want to know your function treats this, where is the 0 and 0, which is usually that point. But make sure about that. So because as we see in the near future, the camera defined the origin different way. The camera might define the origin here, 0 and 0. So that will be converted. There's functions take care of that. So that's, you are isolated from it, but you need to be aware of it, because there will be like some math behind the scene done. We will mention some of it. We are not doing it because the open source functions can do it for us. We need to understand what does that function do, so we can understand what the parameters mean. Questions? All right. So here, this is one of the standard images that's available in MATLAB. If you are using the MATLAB version from the school, I mean, any MATLAB, these come the standard images, the coins here. So for thresholding, that I want to assign 0 or 1 based on the difference. Let's say that the object of interest is the coins, the quarters that's shown in here. So I do not need to use color here. So this is the image, and I'm talking as a machine. The machine sees this is just as an image. The machine doesn't know that's coin or not until it performs some processing. So simplifies the processing and computations by converting it into a gray level image, and you may choose a global threshold. So the threshold can be global, means the whole image will be compared to one value. If it's above, it will be considered foreground, means moving objects or new objects in the scene. If it is below that threshold, we will call it background. So we have a foreground and we have a background. So these colors and this one, these values. Usually the foreground has a higher value. That makes more sense. All right. Or in some situations where the image might be affected by different lighting, it's like some side in the image has effect of shadow more than the other side. So here we will use a local threshold value. So each area will be thresholded separately. That will be adjusted online while you are collecting the frames. So that kind of value called local value, and that approach called adaptive thresholding. Adaptive. Like, for example, car is moving and there's a mounted camera there. So while the car is moving, there will be a shadow and different lighting, either from sun or from lights in the street. So the size of collected images might not be affected by the same amount of ambient light, for example. So in that case, you will look at this as local areas and then you assign different threshold. You are not doing that. There will be function doing some calculations to come up with the best of the optimal threshold that can be used to identify if the pixel belongs to a foreground, which is a new object, or background. All right. So doing so, I got this image. As you can tell in here I used the other way of defining things. Here I assigned 1 to the moving object, I assigned 0 to the background. Here I assigned 0 to the foreground, and I assigned 1 to the background. And there's a function can do that, flip that for you. So if I look at the intensity, so here we look at this figure, shows the intensities. So there's a gathering here, and they have a mean and standard deviation. I have another distribution. So here are the values. Higher values are shown in here. So when you look at, when you are in the stage of designing your algorithm, so you look at the values of several, like 100 images, 1000 images, and you set up your threshold value. So the threshold value will be in here. Anything above T will be considered a foreground. Anything below T will be considered a background. Foreground means new object. It might be object of interest. So we don't know what kind of object is there, but there is something in the scene. Like earlier I said in here, so we didn't find animal, but there is a new thing that I need to investigate. So there is another step later to find out, is there animal there or not? That's another process. But first now just initial determination. I find out if there is a new objects in the scene or not. Question?